My name's Ed Gonzalez. Welcome to the Miami MongoDB Meetup. Tonight we have Mitch Pirtle all the way from New York, freezing cold New York, going to be talking about MongoDB. So turn it over to Mitch and let's hear his talk.
All right, just making sure that the screen sharing is working and the mic is unmuted. All right, can you guys hear me?
Yes, we can.
Excellent. All right, I'm just going to share my desktop and go with that. Should be just fine. All right, can you see my deck?
Yes, we can.
All right, cool. Hi, everybody. Let's just get this thing started. So first, actually, it's kind of funny. I already know the answer to this question because we have a small audience. Typically, when I talk about MongoDB, I want to know about the level of exposure everyone has there. Sometimes I get a room full of people that want to argue about sharding and replica set configuration, and sometimes I get people that don't even know what a Mongo is. They're just told to go get one. So I'd like to know. I have a feeling that there's some people that have never worked with Mongo, but they're very interested. Is that correct?
Yes, that's correct.
All right, cool. All right, so what I'm going to do is I'm going to breeze through this deck and actually do some demonstration on the console to show what Mongo actually looks like when you're working with it. So, yeah, about me. So I'm a recovering Joomla founder. Sorry about that. I've been starting companies for longer than I care to admit. My latest work experience is centered around Node and Go. So I'm a server-side DevOps type guy. So that's one of the reasons why I'm such a big fan of MongoDB. I'm also a huge fan of developer workflow, the way development groups work with each other as a group and how they can get busy and get productive. I also coach youth sports. I'm a husband and a dad. And originally I'm from Oklahoma, so don't even bring up the whole barbecue thing. So rather particular. So let's see. How much time do I got? I think I got, what, 40 minutes or so?
Yeah, that's good. Yeah.
All right, cool. So I got like 60 slides in 40-something minutes. So I'm gonna talk New York speed, and I hope you guys can keep up with me. Feel free to jump in and tell me to slow down if that's the case. So back in the days where the dinosaurs were fruitful and the trees were all short, as my son would like to say when I was young, everyone was using a relational database because, hey, it solved the problem. We needed to store data. The data needed to be clean. We needed to not waste a bunch of space. Resources on a server were charged by the CPU cycle, by the kilobyte, and if you did something silly with your code, it could burn through a year's budget in about a week and a half. So it was a real big deal that efficiency and absolute, consistency of data was key. And that's kind of what we decided databases were supposed to be. And life was good. Then, sorry, I just fat-fingered myself. Anyway, I wanted to make a poke at Al Gore, even though he never really said this. I still think it's kind of funny. But the internet came, and that changed some things because now we have more than just 5 or 10 users at a time accessing an app, and that means the amount of data that's there is growing, and the number of people accessing that data at the same time is growing. And then we had a lot more different programming languages show up, and that meant that we had many applications accessing the same data store. So suddenly a database actually became what we now know as a database, where it was a database server or servers being accessed from a bunch of different platforms and doing a bunch of things at the same time for many masters. And back then we all were using Oracle and DB2, right? And then there was a token few who used Fourth Dimension and Fox Pro and God knows what.
Alpha 4.
There you go. Anyway, and then things started really kicking up, right? So we had the World Wide Web show up, and that changed the scale of everything for us, right? And then suddenly the number of users went from, and I'm joking, from 2 to 2 million, but it's true. I mean, the big Joomla website I launched was a jet setter actually for Guild, and when it launched, we had 2,000 concurrent users when it went live. The site before that was for MTV, which peaked at something like 60 million page views in a week. You will never see that in a corporate intranet. I don't care how big your company is, right? And so the needs of a database went totally sideways when the World Wide Web showed up. And that last line there is absolutely true, right? That smoking crater in the data center. Yeah, that was your database server, right? So, and there were some not so subtle changes happening on the developer landscape as well, right? We had many languages, and every single one of those languages were referring to your data structures as objects, right? On top of that, all of these languages had frameworks, and the frameworks were using objects as well, and they were all connecting to relational databases, which was a bit strange because that produced something we call the Object Relational Mapper, or ORM. And the reason I bring this up is that the ORM serves a purpose, but what it really was it a shim to make it possible for us to use relational databases to store non-relational data for non-relational applications. So what we were really doing was, you know, I'm in metaphor crazed moment right now, so I want to say lipstick on a pig and many other different examples, but ultimately we weren't using the right tool, but it was the only one that we had available at the time, so we made do. Then, thanks to the ORM, we started using what's actually the Rails guys I hold responsible for this idea because they were the ones that pretty much spearheaded it. You had models which were representing things, and you know, models had relationships with other models, and they could be, you know, part of or included in, and so on and so forth. Well, that, you know, we can do this, right? So everybody just kept on coding. It was all good. And then we had lots of data and lots of expectations of what happens to that data. So we built even more features into the relational databases to keep track of all these things that we were trying to do, right? We had stored procedures, and we had triggers that were firing the stored procedures on, you know, insert, update, delete, and so on and so forth. We had foreign keys so that we could keep things clean. So if you had users and all were pointing at states, you could make sure that everybody had a valid state ID and all that other stuff, right? And then the World Wide Web really came crashing down on everybody, right? And that's okay. We got this. We're going to manage, right? So I like to call this super mega whack daddy growth, right? We came up with sharding. The guys at, let's see, was it Danga Interactive were the first ones? No, they were Memcache. They came up with the Memcache concept. Facebook and many other sites actually came up with what we call sharding, which is basically, imagine if your database server, actually this is really funny. So the quick story is one of the startups I was involved in very early on was Classmates, back before they became a spam house. And Classmates contacted me because they had a unique problem. Back then, Linux was a 32-bit file system, which meant the biggest file you could fit on there was 2 gigs. Well, they were using MySQL, and they were also using MyISAM for table storage, because that was all that was available back then. InnoBase was still not even in the early alpha stages, I think. And so each table's data was stored in one file. Well, the users table was at 1.9999 gigs, and these guys were sweating bullets. So what a lot of companies did at the time was we came up with something called sharding, right? We decided, okay, everybody whose login starts with the letter A goes to this database. Everybody whose login starts with B goes to that database. So you could basically spread your data across multiple physical machines so you could get around that physical limitation of a file. Well, the problem there is that now you can't just say, get me a count of all my users. You have to say, okay, for each shard in my cluster, go get me a count of my users. But then even more so, you would say, I want a count of all my users who are friends with each other. Or I want a count of users on my system who don't have any friends at all. And suddenly you're no longer able to just run a couple of really quick queries, right? Then we had another issue, which was concurrency. If your writes were happening slower than people were trying to insert data, then your website was eventually going to go down because your database couldn't keep up with the traffic. That happened to me at MTV. It was a teenage girl website. Talk about a tough crowd. And you're talking like 2 million teenage girls all trying to tag and friend and write lyrics and have polls and quizzes and, I don't know, talk about Harry Potter and that Draco Malfoy and all this other stuff. So with all this crazy action going on, there was just simply no way we could manage with one physical server all this data getting updated in real time. So we had to cluster. We also had to multi-master. So we ended up using 5 database servers. There were 2 masters that were clustered, and then we had 3 servers that just did nothing but execute slave queries. Now, to pull this off, because it was a Joomla-powered website, actually we used the Joomla framework, not the CMS. And we had to hot rod the database class and the config class is actually what I did. So that whenever I did a regex on the query, the SQL for the query, and when I saw select, I sent it to the slave connection. And when I saw anything else, it went to the 2 masters, the cluster. And so what you find yourself doing is, instead of writing application code, you write code to manage the interface between your application and the database, right? And that's really part of that whole polarity mismatch that we started seeing back in the day. And that, resulted in one of my favorite images here. We found ourselves wrapped in the arms of the octopus. So, okay, we don't got this. And this is where MongoDB comes in handy. Now, MongoDB was founded by Dwight Merriman, Elliot Horowitz, and a handful of other people. I don't want to miss any names out, but I'm kind of trying to go in a hurry. And they came over from, actually, originally, I believe, they got their claim to fame doing DoubleClick. And I remember Dwight once saying, Mitch, I would kill to have used something like MongoDB back in the DoubleClick days, because we had so much data, and we were so desperate to do inserts. And we were so desperate to do live queries on that data so we could provide the analytics and the research that, man, I would have done anything to have access to this. And that's exactly the problems that MongoDB attempts to solve by being a document database. I'll hop on the console and show you this later on in the talk. Yeah, this is something that I saw. But it's not ACID compliant, right? And the funny part is, we convinced ourselves over the years that a database wasn't really a database unless it was ACID compliant, right? Well, those days have changed. ACID is now something totally different, at least to me. Anyway, so somebody on YouTube says, yeah, but it's going to lose all my data. And I said some sucker on the internet, because that's actually true. I'm actually kind of frustrated about this. I'm going to be glib and put up a Star Trek reference, but ultimately you can say, hey, Mongo, save this, and don't come back to me unless you've committed this save on at least 2 masters and 5 slaves. And then you pay the performance hit of waiting for all of those transactions to take place. So Mongo is not going to lose your data. You can lose your data if you don't know how to use Mongo properly. That's really what's going on here. So probably the biggest thing about MongoDB is that it stores data as JSON documents. Technically speaking, it's storing them as a serialized binary representation called BSON, and that's available at bsonspec.org, I believe. That's an open spec from the MongoDB guys. They're very big on sharing their research and their tech. They're actually releasing MongoDB under the AGPL license. So if you make any custom hot rods to the MongoDB database server itself, they're expecting you to share them. That's about as open source gets. Also, you have sharding and clustering is built in, so you don't have to download additional libraries and do all kinds of weird, strange, unnatural gyrations to make it work. You got slave and replication as part of that package. Now, the most important part is that there are no joins. This is not a relational database, and that's actually what I wanted to talk mainly about tonight, because that's the pitfall that most people fall into when they first get started with MongoDB. And this was the first question that most developers think, right? How am I going to manage joining across 8 billion tables, right? This is Oracle Financials, man. And honestly, what you need to do is denormalize your data. It needs to be organized just like you're organizing your code, your application code at the top level, the logical level. And what that means is that you're going to store each thing as a separate thing, and that is an atomic write, or transaction, as you will. All right, this is kind of silly. Your relational data looked like this, and your document model looks like this, right? Easy as pie. All right, so once again with feeling, folks, relational data, document data, relational data, document data. So, enough already, so I'll get serious. So, a relational database might take a user table, for example, where you spell out first name, last name, email, password, and so on. That's no big deal, right? All right, well, we're not exactly done. So now we also have an address ID, which refers to address records by the .id on that table. You might have a gender ID. Hey, it's the new millennium. You got multiple genders now, right? Then you have an account type ID. You might have a bunch of other tables. Now, I always called those not just relational tables, but if you have a many-to-many relationship, you get stuck with something which is, in old people like me, call a tie code table, meaning you have uh, table 1 and you have table 2, but then you have a bunch of 1s that can be related to a bunch of 2s. So you store them in a table 3 of 1 ID and 2 ID equals a 3. That's okay. We got this figured out, right? All right, well, what if I have 2 addresses? Dull. So now you got to go back to your code. When you're done with that, you have to look at how you update your table, right? So, well, okay, we'll insert the record in use. Well, okay, first we insert the no, wait. Oh, crap. Right? Now, a lot of us have fallen into that pitfall, I'm trying to find the word, that hole, where you're stuck trying to figure out what goes in the database first, because it's all tied to each other and it's scattered to 4 corners. How do I deal with this? Now, with a user document, what ends up happening is you get an ID. That's actually not a proper ID. Sorry, I cut and pasted from a wrong window. And you might have a first name property of Mitch, last name Pirtle, and then notice under addresses, you'll see those square brackets. That's an array. I just put 1 so it would fit on the screen, but ultimately you can store an array, a list of things inside another thing. You can also embed a document inside of another document. And that's probably the most important aspect of working with MongoDB. And yes, that's all JSON. So those of you that are coming over from the front-end world, and this is actually kind of interesting, the folks that have been working with Angular and all the jQuery and Ember and all the different JavaScript environments, they're looking at MongoDB and they're like, oh my God, I can use a database and it makes sense. And now here's the stuff that I remember falling into when I first got busy with MongoDB. One was the biggest mistake you could possibly make when you're evaluating MongoDB is to just bring over a relational data model into MongoDB. That's like slapping wings on a car and then complaining loudly that it doesn't fly very well. And you're not going to get very good results, so don't expect anything good to happen when you take that approach. And again, there's a lot of complaints about, yeah, but it doesn't do transactions and rollbacks and all this other stuff. Well, if you want an atomic write, it's at the document level. So if you really need to do that kind of stuff, you need to think about each document as a separate, self-contained entity. And then the last aspect is that there are utilities in MongoDB to do just that. A common command that people just discover and like, oh man, that's it, I can live here, is find and replace. I have a real good example of that one that I'll get into later. So excuse me while I whip this out. I had to have a Blazing Saddles reference. So I'm going to go to the console here and show you just how terrifying MongoDB actually looks. And for posterity, I'm going to see how big I can make my text. Boom, 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 boom. That's not even the right console. All right. How about back? Oh, that's tough. Hello. Come back to me. There we go. That's kind of frustrating. Sorry about that. All right. See if full screen works. No. Full screen is fine. Okay. So much for that idea. All right. Let's try again. Okay. All right. So I have just a stock version of MongoDB installed on my Mac. And you can use Homebrew on the Mac to install very easily. Just brew install MongoDB, and it actually installs it. And then when it's done installing, tells you what you need to do. If you want to auto start MongoDB at startup, if you want to manually fire up Mongo, Mongo's actually out of the box extremely simple to run. It's very similar to Memcache. In fact, it's technically simpler than Memcache to run because you actually don't specify how much resources MongoDB uses out of the box. Now, I'm going to stop and explain that. Mongo 2.6 is the latest stable release series. and it uses memmap for file storage. Now, there's no way to tell memmap I want a database that is no bigger than 20 gigs, for example. So what you end up doing is you can fire up a container or a virtual machine and give it only 6 gigs of RAM, and that's where Mongo runs. Now, the latest major release is actually called Mongo 3, which is not out yet. It's going to come out in a couple of weeks. And it's already in release candidate. I think release candidate 8 is out right now. And it uses a new storage engine called Wired Tiger, and that is kind of like the MongoDB equivalent of InnoBase storage for MySQL was. And funny enough, MongoDB, the company, just acquired Wired Tiger as a company, which was founded by the guys behind BerkeleyDB. So this is actually a very good move for the MongoDB project and company, because I think that those are the exact people that they need under the hood worrying about actual data storage on disk. So Wired Tiger gives us a lot more configuration power over how much resources MongoDB uses, where MongoDB is storing that information, and how it stores that information and whatnot. So I think Wired Tiger is a very good thing for MongoDB. And as a product, I think it takes it kind of into the enterprise space where you're no longer just, running MongoD on a server and just boom, your memory's all gone. Now you can actually control what resources are being used and be a little more particular. So let's see, show database. So we have all these databases. I've been playing around with the mean project, and I have a couple databases there. So I'm using test. If I want to see the number of now, Mongo calls tables collections, right? And that's something to consider. Now, I created a collection called things. So, what do I have? Does this look like JavaScript to you? I'm going to assume that the answer is yes. It is. It's basically SpiderMonkey running on the server. Right? So, let's see. How about we'll just find one thing. So here's a thing. It has an underscore ID property, which every document in MongoDB gets. And then I also gave it a name and called it Thing1 as a Dr. Seuss reference there. So what this means is that whenever you insert a document into a MongoDB collection, you're going to get an underscore ID property set. Now the reason this is important is because by default, that's what MongoDB is going to be using if you ever turn on sharding or any more sophisticated features of the database engine. If you're just generally using the database, then it probably doesn't matter all that much. I typically just leave it alone because I rarely have a situation where I must have a different primary key. Now, underscore ID is automatically indexed, so in my eyes, you might as well use it. If you really want to have another key, then what I would do is create a second key on that property and make it unique. MongoDB does support indexes and supports unique index constraints as well. So now let's do, let's just do it simply. So I'm just going to say find all the things in my database. There you go. I'm going to find, this is one of my favorite things to do, find and make them pretty. Ah, there we go. That's much nicer, isn't it? So what you have here, and this is kind of important, is I've created 5 sample documents. They all have a name property. 2 of them have a color property set to a string, and 1 of them has a flavors property set to a list. Now this is what's interesting. So let's do find pretty where. Let me make this a JSON document. Flavors is amaretto. I just came back from living in Italy, so this. Okay, what am I doing wrong here?
Shouldn't it be in the find instead of pretty?
Oh, yeah. Thank you so much.
Yeah.
Sorry, I forgot that I was doing pretty. I wasn't even paying attention.
It's okay.
Right. So there you go. Now what's really important here to consider is that I didn't say where flavors has a string that's in the flavors array. I'm actually saying there's a property called flavors, and there could be 1 or more things in there. It could be a string, could be an array, could be an embedded document. Find it and then see if there's something in there called amaretto. And it found that document. That's really important because one of the things that I experienced as a developer coming over was Mongo's ability to look inside of a document and find documents based on properties, whether it was a list or an array, one or more, was really that was a profound change as opposed to your very strict and structured world of SQL where you define a particular column as a character 32 padded with spaces, for example, or a variable character 32, and so on and so forth. Or you have to store it as an array of strings, and you have to do an in for that query. Now, this is a good thing in the beginning. I got muted. Can you hear me now?
Yeah, we can hear you now. You were cutting in and out a little bit, so.
Okay. Sorry about that. All right. So let me go back to the console. So one of the big changes for me was the fact that I could search for a document based on a property, and Mongo was smart enough to see if that property was a string or an array or whatnot, which was great for prototyping. However, the big caveat there is that 6 months later, you can look in your users collection and find that you have like 20 different types of user documents in there. So you have to make sure you don't find yourself with a veritable college dorm room of data later on. The fact that MongoDB is schema-free is a great thing, and it makes prototyping awesome, and you can actually use it for unstructured data as well, which is really cool for analytic systems and a bunch of other stuff. But that doesn't mean it's smart to just dump random types of data in the same collection and expect to get any use out of it later on. The last thing here is you're looking at just plain JSON documents in here. There are many different data types. There are strings, integers, dates. There's also a GOIP function. There's many other facilities to the language. To the database engine. So what I'm actually going to do here is drop and go back to the browser. Infinite loop! All right, so here we have the MongoDB main website. And there you actually have the documentation. And something that I find intriguing is they're really good about their ecosystem. There are a bunch of, I'll make this larger so you can see. They support many languages out of the box, and that's meaning proper support, as in the MongoDB people actually support the connectors to these languages. But there are also third-party environments that are supported by community and whatnot. So there's a lot of interesting information here. So when you click on the MongoDB ecosystem, you'll see a lot more information that's useful. So now I know that one person there was talking about JavaScript, so I'm going to assume that you're coming over from Node land. Is that correct?
Yes.
Yes.
All right. So quickly, this is the native MongoDB Node driver, and this is actually maintained by MongoDB. It's very important. So this basically gives you exact access to the database as is. Now what they've also done is they've taken the Mongo native driver and they've added some special sauce to it, and they called it Mongoose. Now Mongoose allows you to use Mongo from an ORM-like perspective, but what you're really doing is you're just mapping schemas to your collections. So here you can see just a very simple example, they like cats. So there you go. And it's very easy to use Mongoose. Mongoose is very commonly used in the Node world, and that's almost taken as a given for a lot of projects. Basically, every Node project I've ever worked on that had Mongo under the hood was using Mongoose. It was kind of like just a given that that was the driver that we were using. That said, one of my favorite tools as of late is a Node framework called Loopback from the Strong Loop folks. And the reason why I like the Loopback framework is it basically, you use Loopback to build, in a sense, an API service, and it is crazy fast how quickly you can do these things. So for example, I'll go over here. That's it. So So I basically created a loopback project here, and then I ran the model generator for a model, and it was a very simple model. Let's see. In here, models, thing.js. So that's where the functionality for it goes. And JSON, this is what it actually looks like. That's what a thing's schema definition is, right? So I gave it it's a thing. I said the plural was thingies because I'm just being silly because I'm a silly person. And then I said the properties, we have a name, which is a string, and it's required. There's a flavors property, and that's a string as well. Colors property, that's a string. There's no validations or relations or anything else, no security or ACLs. And that's basically it. So at this point, you just run it. Wait for it to fire up. I'm on an older laptop today. Apologies for the blazing speed.
That's all right.
It's funny, my fancy schmancy $8 million laptop with the SSD and 16 gigs of RAM keeps dying on me, and I keep going back to the old beater with the 5400 RPM maple syrup drive. All right, so Pore 3000. So this is basically what you get. You get an API service, right? And what did it say when it fired up? Browse your REST API here at Explorer. So we'll go there. So here you see that it generated thingy. So all I did was tell it it has a name and a so on and so forth, right? Well, this is what the loopback framework built for me. If I can zoom in a bit and make the text bigger so it might be easier to see. So you get all of these routes put together, and we have post, get, delete, put. We have basically every HTTP method under the sun represented. We have accessors for finding and modifying things by ID. You can get lists. You can check to see if that thing exists or just get a count, or you can just randomly select something. So this is really powerful. If you're building like an Angular JS app and all of your logic is living in the browser and you really need a database just to be a database, for crying out loud, and not have a bunch of other stuff, this is it. This is like the fastest way you're going to be up and running with it. So I just wanted to show that. I have nothing to do with Strung Loop. Actually, I don't know anyone there, but I just thought I just played with this the other day and was really blown away.
Looks powerful.
Sorry?
Looks powerful.
Yeah, it's incredibly powerful. So at this point, I'd like to field some questions. I don't know how much time we got left.
We got time. Yeah, we got time. Guys have any?
Actually, yeah, we can go on. We are fine. I mean,
No questions?
No.
No questions, Mitch. I think you've done such a good job that you've left them questionless.
So I put everybody to sleep, I hear.
No, it's good. I was like,
it was the pizza. I blame the pizza.
yeah, there you go.
Yeah, so I mean, playing around with MongoDB is easy to do. The number one thing to keep in mind is that you can't build a third normal form data model in Mongo and expect it to be a fun experience. You really need to think about what it takes. Oh, there you go. My one shameful story about MongoDB. So I was launching a startup, and actually I can talk about it and everything. The startup was called Totsi, and it was a private sale website, and we had something like 4 million moms would all log in. I'll go ahead and go back to video. Like 4 million moms would all log in at the same exact time, right? And then, yeah, I'll go ahead and go to video. And they would go to the reload key, and then they would just, right? They would just hammer this website because they wanted to get that organic crib made in New Zealand or whatever, right? So getting inventory straight was a big deal. Actually, I can even tell you the actual details. We were running a sale. It was for Bugaboo strollers. Okay, these were like the big $800 strollers. These were the big, Battlestar Galactica strollers, and we were given something like 50. And what happened was, in the data model, I created a collection called items. And so for each type of Bugaboo stroller, I had one document. Here's the name, here's this SKU, here's this style and everything else. And then in the document itself, I said, here's how many we have available, and here's how many are in shopping carts, and so on and so forth. And what happened was a logic bug in our code made it possible for multiple moms to add the same Bugaboo stroller into their cart. We ended up selling like 115 strollers, and we were only given 50 by Bugaboo. So we were bailed out by our products guy who had deep connections in the industry. He called him up and said, "We need more strollers. We need more strollers," and we managed to pull it off. But ultimately, that was a bad design. Now, in a relational model, you could do something like that and get away with it because you would be wrapping everything in a transaction and so on and so forth. What I did to get around this problem in MongoDB was instead of having one document that says this black model 2322A stroller has 15 available, I actually inserted 15 documents saying, "Hi, I'm the black model 2322-A stroller, and I'm available." And then we used a command called find and modify, which basically is an atomic operation in itself, where you say, "Mongo, get me an item that's a black, 2322A-C stroller that says available, and update it so that it says not available and is in my shopping cart." And at that point, now I can hit the database, and in real time I can see not only how many of these strollers are sitting in the warehouse, so to speak, waiting to be sold, but I also could see the number of these strollers that were in shopping carts, and I could even see whose cart they were in. So it made it really possible for us to do some cool stuff. It's like an unintentional side benefit of doing that. And the last thing that I want to mention about MongoDB that I didn't mention at all in my presentation, which I kind of feel like a fool for doing so, is that when we launched the Totsi website, I was terrified. Okay, the entire website stored all the data in MongoDB, even the session data, even the product images. We use something called GridFS, which lets you store binary objects in your database. Right, it's kind of like the Oracle blob equivalent, if you will, but it's infinitely smarter, and it's just a tiny bit of C code, so it's crazy fast. So we launched the website. We had 2 web servers, quad-core machines with like 4 gigs of RAM, your general garden variety dedicated servers. And then we had 2 database servers that were running as what's called a replica set, or multi-mastered pair, if you will. And we went live, and the first thing I did was log into DB1. "Okay, DB1, how are you doing?" And DB1 had no load. And I thought, that's it. Not only do I lose my job, I just killed the company. That's it. It's over. The website's dead. There's no way we're going to be able to recover from something this stupid. I can't believe it. And then I would go to the website, and I saw that the pages were still rendering, and I'm like, oh, how sad. So people are basically shopping, thinking they're shopping, but the database is down. And, oh, my God, I can't believe this is such a disaster. And then I went back to DB1, and I did something smart this time. I actually logged into Mongo and started running some queries. And sure enough, there they were. There's the shopping carts. I'm seeing them going in and out of shopping carts, and I see order records being created. And the president of the company, his name was Christophe, a rather flamboyant Frenchman, started dancing through the office, ka-ching, ka-ching, ka-ching. He was all excited because he could see all of the transactions on the credit card side of things. And I thought, okay, hang on for a second. So nothing's dead. All right. So then I logged into Web 1, the web server on the front end, and the Web 1 was like, heavy load, having trouble, help. And it was really funny. So I was terrified that the database, because that was always our primary source of pain when it came to scale and performance, actually this was the perfect storm for MongoDB's function and feature set and implementation strategy, because what happened was the first mom to hit the website would hit the front page that showed you a list of sales that were running that night. Well, that query is run once, and then it's cached in memory, right? None of those records are getting updated, so they stay in the cache. Now, if we were to do the same thing with, say, MySQL, what's going to happen is that front page is going to have a query that's probably going to join over 15 to 20 different tables to figure out which sales events have inventory and blah, blah, blah. And how long do you think that's going to stay in the query cache? It's going to stay until the first person adds a product to a cart, and then it falls right out of the query cache, because all it takes is one table out of all 15, and that monster 15 table join, for example, and boom, it's out of your query cache. So the query cache can't really save you in the relational world. They make it sound like it's this huge savior, but what really happens is if you're really using a third normal form data model, then one of those tables is getting updated constantly. So nothing lives in the query cache. You're constantly stuck operating at hard drive speed, which all of us know is not acceptable for web scale, right? Okay, so your first mom clicks on the Bugaboo sales event. Well, she runs a single query that says, get me a list of all the Bugaboo products in this sales event. Well, how often is that query going to change? It's not changing at all, so it stayed cached in memory. So what happened was, for approximately 500 milliseconds, Mongo had to run 15, 20 different queries, and then everything for the entire website was cached in memory and just sat there. So Mongo had no load. At that point, we could have been writing to flat files and probably wouldn't have gone any faster, right?
Yeah.
So your use case is really, really important as to how you can take advantage of MongoDB and how MongoDB works. In the private sale market, I discovered that it truly is a silver bullet, and you're a fool not to use it. For other websites, especially if you're doing like analytics with like random queries and stuff, Mongo can also be an extremely powerful tool. Now, if you're in an environment where you have data spread across multiple collections, and it has to be from a logical perspective, but you need to be able to do group updates across many collections at the same time and have rollbacks and all that kind of stuff, then you are going to need to use a relational data engine because you've got a relational model, right? So really the best aspect of MongoDB is when you try to find a use case that doesn't demand a relational database. Now, coming from the CMS world, for me, that's 10 out of 10 projects, the data is documents. So for me, MongoDB was like an immediate perfect fit, right? I've been launching companies and sites with MongoDB since, I don't know, 2006, something like that. So yeah, so I launched the first e-commerce website that used MongoDB for all data storage, for example. And so I've been doing it ever since. I haven't found a situation where MongoDB was not a good fit. I've had situations where MongoDB might not have been a perfect fit, but that was because it was an edge case, weird situation where no database was technically a perfect fit. That said, my favorite combo right now is actually MongoDB and Redis, because the two combined pretty much tackle, they overlap just enough so that I can cover 99% of everything that's been thrown at me. I can take care of with one or the other of those two engines.
Wow.
Anyway, so thank you. If you do have any questions, feel free. I'm going to put my deck up on SlideShare, and actually, yeah, I can go back there, so everybody can see that. And yeah, thank you for having me.
All right, Mitch. Well,
Thank you.
thank you very much for your time. We appreciate it, and I don't know where you're. Let me stop the broadcast. Hold on.